Okay, so the talk today, it's about embryologists and why should you test your pH. So I think that this slide, it tells very much what's going on in our laboratory. And if you look at it, it will tell you that there is about almost 200 factors that will impact the outcome of an IVF cycle. And these are air quality, pipette, microscope lights, and so forth. But I think within this talk, what we're really interested in is in the incubator gas temperature and the CO2, because that is really sort of the idea of the talk today. So what are some of the sources of stress to the embryo? Well, certainly there are technical issues. The way you handle and store media, oil, the way you make dishes, pipetting, and embryo density. By embryo density means how many embryos do you have in a drop. Also various mechanical and chemical stressors such as toxin, oxidants, light, and more importantly about culture wear and plastics. The other thing is culture media. And we know that laboratory can actually have an impact on the efficacy of culture media. Oxygen, do you culture in low oxygen or at atmospheric pressure? And osmolarity, temperature, and pH. And I think the last three factors there are really, really critical part of your culture system. So what is pH? We always talk about pH, but what is really? Well, in its simplest term, pH is the measure of hydrogen ions concentration. And if you really want to see a great review about pH, there is an old paper by Dr. Poole in 2004, and I think every laboratory should look at that. It's really a balance between incubator and culture media, specifically the CO2 level within the incubator and the sodium bicarbonate. And although there are other substances that can influence pH, really that's kind of the most important. But an important concept of pH is that pH is dynamics. So it depends on association and disassociation of compounds within that solution. And factors such as temperature can really change your pH. So why do we care? Well, we know that there's some physiological importance of pH. In the oocytes, we know that denuded M2 oocytes lack the ability to regulate pH. So it's very important, especially right after ICSI, when you denude the oocytes and you're putting it back into the culture media just before ICSI, you want to know that that outside pH balances and it's sort of in prospect with your oocytes. Unlike the embryos, oocytes do not possess functionally pH regulatory. It affects mitochondrial localization and therefore developmental competency. And it also can affect oocyte metabolism. So sometimes we think, well, why am I not getting good fertilization, or what's going on with my oocytes? Well, it certainly does that, and it's been correlated with maturation and developmental status. Is it important in embryos? It is also important with embryos. So changes in intracellular pH can impact metabolic activities, intracellular organization, and embryo development. It also impacts blastomere division, fragmentation rate. So if you're getting a lot of embryos with fragments, you may want to look at pH. And just overall, your embryo morphology. The other thing to remember is that cryopreserved and odd embryos also do not have a very good balance in checking pH. So there are really three phases of pH dynamics. There's an equilibration, a set point, and a stabilization. And I think the most important thing of this slide, if you could take it away, is that equilibration can take anywhere between 10 and 14 hours. So when you're putting a dish in an incubator and you want to do it right away, you really have to be aware that it takes that long. The set point should be somewhere between 7.2 and 7.4. And again, this is very much on your CO2 and bicarbonate. And also the stabilization of pH can fluctuate with the oil, your relative humidity, the type of buffer you use, the size, and even the altitude. So this is a paper from Jason Swain, and I would sort of recommend that everybody takes a quick look at it. It's very, very good. Factor that impacts equilibration, your oil viscosity. If you're using a heavier oil, you want to make sure that it equilibrated a little bit longer. The size of the drops, the type of lid or dishware that you use, and also the amount and type of protein. So oil overlay is very important. It is really your friend because it does stabilize pH, it stabilizes your osmolarity, it traps VOC. But one important thing is if your oil is toxic, if you do not handle oil well, it could be your enemy. And therefore storage is crucial, and the oil should not be aliquot in stearine flasks because that is very toxic. So the oil picks up this toxicity from the stearine flasks. So this is just a little bit of a slide that Klaus Wiemer kindly let me use it, and it's just really a graphic of what we talk. This is how long, so, let's see. But this is how long it actually takes for media to reach stabilization and sort of going through all the three phases that Jason talks about it. Factors that will impact pH in your within your incubator. We're looking at the length of equilibration. So really you need to be sure that you do put those dishes in for a long period of time. How often do you open your incubators? If you don't have enough incubators in your laboratory, you could be opening quite often. The type of sensors that you have. So you need to be aware that not all the incubators have the same type of CO2 sensor. Where is your HVAC? Is it right on top of the incubator? That will make a change. Temperature changes within the incubator and humidity. So that's other factors that you want to keep in touch. This is just a graphic representation. You could see it in the first slide here. Just having less oil overlay, it really is drying up the drops. As if you're putting even more, just 15 microliters more. These are small cups, but even 15 microliters more just really makes a change in your osmolarity and final pH. This is an old slide from Dr. Poole, but again, the idea is that here we want to look at the green line is the incubator, the other two are CO2, and the top line is the actual pH. And you can see that even though the two measurement fluctuates, the pH is very stable. So for media, we really want to change. We want to look at pH, not so much because you have to keep in mind what kind of CO2 you're measuring at. And this is just another slide from Dr. Poole. And you can see that even though there have been a fluctuation in pH right here, the Fryrite did not pick it up. They didn't pick up that there was an actual change in CO2. So very important to know the type of sort of tools you're going to use in order to change to check your pH. A little bit of, again, this is some work from Jason Swain. You want to see that not all culture medias are created equal as far as pH, so you really need to know what kind of culture medium you're using. So they're different between Sage and Irvine and Vitrolife and Life Global. So really be aware of the type of media that you're using. This is just, again, another slide that you should totally be aware of, is whether you're adding protein in the lab or whether the proteins have been added by the company and the type of CO2 that we are talking about it. So for example, in here, if we were to look at a 6% CO2, you could see it that post-supplemented is within the correct range of pH, but the pre-supplemented, so meaning the ones that we've added in the lab, is a little quite off. Vice versa, if we go to the 6.5% CO2, you could see that the post-supplemented is off range, but the pre-supplemented is very much within the range. So you want to be aware of what you use in your laboratory. And what about altitude? This is why it's important not to talk about what we're going to set our incubator, but where are we? So altitude has an important part to play on pH. Someone in Denver is not going to have the incubator set up the same way as Philadelphia. Okay? Altitude play a huge impact. So you need to be aware of where you live and how you're going to set up your incubators. So question very important is, how do we measure pH? So the most important thing is that you have to have accurate, reproducible measurements. And you need to be aware of several issues, those being temperature, does the media contain protein, heat piece, altitude, all those will have an impact. If you're using a pH meter, again, very important to calibrate your device. So you want to know about your buffer, your electrodes, and you want to validate the accuracy before you start using it. You need to be aware of your gas tanks. What is the plus or minus that the gas company has in your region? You want to ensure that your CO2 levels is in the incubator is independently validated. And I think the frequency of testing, really it's up to you. It's about your laboratory and how you want to set that up. But you should be consistent with that. I think the other important thing is you need to differentiate whether you're doing testing or monitoring. There are a lot of devices out there. They're all very good, but you need to be aware of the difference. And important is that you need to maintain a very narrow and stable pH. So I just want to show you an example. If you have a pH meter and how it's easy to make sort of run into a problem. So if you calibrate your pH meter, but you're going to calibrate it at 22.8 degrees or 37, and then you're going to measure at 37, even though your CO2 is completely stable, you can see that your pH results are different. And one is going to be correct and one is going to be wrong. Okay, so if you have a pH meter, okay, and what you're going to do is, if your pH meter does not have a temperature probe to correct the temperature, okay, what you're going to do is you're going to calibrate your pH meter at room temperature, right? But then your sample is coming out of the incubator at 37 degrees. So even though your CO2 is the same, it's going to give you a wrong or a different pH temperature because the calibration and the samples are at two different temperatures. Yes. So in conclusion, some of the factors that will impact your embryo development, it's going to be, you need to have steady media. You need to be within that pH range of the media that you're using. So therefore, your CO2, your temperature, the composition of your media, all play important factors. You want to have a steady osmolarity. It's very crucial. And therefore, oil overlay. Again, extremely important. Just to acknowledge some people that actually helped me out with the slides. Klaus Wimmer, Don Rieger, Jason Swade, and Tim Schimmel. Thank you.